Alright, climates on Earth for chapter 18. We'll be going pretty quickly through this chapter as well. Um, Make sure you ask questions in class if you got them. So, climate is a long-term average of weather conditions that occur in a particular region. Rain shadow is an area of low rainfall on the downwind slope of a mountain. Specific heat is the amount of thermal energy needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius. And a microclimate is a localized climate that is different from the climate of the larger area surrounding it. The important thing for me that you remember for climate is that climate is over long term, weather is short term. So climate is over years and years and years, and weather is that day. So climate is the long-term average of weather conditions. So this is the average temperature and the average precipitation, and how we also use this to determine how things change over time. Factors that affect climate. Latitude. The equator is at 0 degrees, the poles are at 90 degrees north and south. A higher degree means less direct sunlight. This is due to the Earth's curved surface, and it depends on the angles that the sun's rays hit the Earth. This causes the poles to be colder than the equator, and it also is what causes the seasons. So, this would be during a southern summer or our winter. If you notice that these rays have further to travel to get to where we would be, and that makes the angle increase. So here's where we have a pretty strong angle. Right here, we have a very direct angle. That direct angle is going to lead to very warm temperatures. If it were, say, the equinox, which is the days that the equator is facing directly at the sun, then the equator would be straight across right here. But the picture that we have is a northern winter and a southern summer, so the southern hemisphere is getting a lot more direct sunlight. Here we can also see that if we have the sun coming from over here, we have a longer distance to go through the atmosphere, which decreases the amount of energy reaching the surface. Also, we have the same amount of energy hitting a larger area. Here, we have the same amount of energy as up here, but it's hitting a smaller area. So if we have the same amount of energy hitting a smaller area, that one area is going to be hotter than this large area. More factors that affect climate. Altitude. As altitude increases, temperature decreases. This is true in the troposphere. I think that we probably should know that. Rain shadow. This is a unique precipitation pattern. Mountains cause warm, moist air from the ocean to rise. This is going to be water vapor, WV. Water vapor cools, condenses, and falls on the upwind slope. Should be slope of the mountain. Dry air then passes over the mountains and sinks, leaving dry conditions on the downslope. So, here we have the water evaporating. That's what gives us the moist air. That moist air is pushed up the mountain, so warm moist air rises up the mountain. As it rises, it goes into colder temperatures. As it goes into colder temperatures, it condenses. When it condenses, precipitation forms on the windward or on the upslope. So we're going up here, so that's the upslope. After it drops all of its rain, the air mass is now dry with no water vapor. So this region right here is called the downslope. And it's also the rain shadow. Because there's no water in this air, it's very, very dry, and a desert forms on the backside of a lot of mountain ranges. Large bodies of water. Water has 6 times the specific heat of sand. It takes 6 times more thermal energy to heat up water by 1 degree Celsius than it does sand. So it just takes a lot more energy to get water warm. So due to specific heat of water, climates near large bodies of water have more constant temperatures than those that do not. So things near the oceans are more moderated. Like if you went out to, let's say, New York or Boston, one of those two places, it would be chilly, but it wouldn't be the kind of cold that it gets to be in the winter. So we have really, really hot summers and really, really cold winters. Theirs are more towards the middle of both of those things. And it's even more true out on like the West Coast, where in San Diego it's just kind of nice all the time because of their latitude and the fact that they're so close to water. So warm water currents keep coastal areas warm, cold water currents keep coastal areas cold. Just depends on where your water is coming from. Alright, so the system for classifying climates was developed by Vladimir Köppen in 1918. He based it on precipitation, temperature, and native vegetation. We're going to focus on 5 climate types. Within these types, there are subtypes that we're not going to spend a whole lot of time with. So polar climates are cold year-round and have minimal precipitation. Continental climates have warm summers and cold winters with moderate precipitation. That would be us. And dry climates have hot summers, cooler winters, and very low precipitation. Tropical climates are warm year-round and high precipitation. And mild climates have warm summers, mild winters, high precipitation, and humidity. Here on ours, we called this mild. They're calling it moderate. It's the same idea. But you can see kind of where we land with this. We'd probably either be humid continental right in this area, which is what I would say that we are. You start going north, you get into the polar areas. See that over towards Arizona and New Mexico, we start to get in the dry climates. So it's pretty straightforward stuff, hopefully. A microclimate, like we talked about, is a small area that has a different climate than the larger area surrounding it. So what we see with these are a lot of cities. So areas with a lot of concrete are warmer. The concrete absorbs more thermal energy. This is called an urban heat island. It happens in cities, like I said. Forests can also have these microclimates. There's less wind and they're cooler because they don't get the bottom of the forest floor doesn't get as much air or light as the top of it does. Hilltops are windier. Hilltops also cause this sunny slope on one side and shaded slope on the other side. There's not going to be quite as much vegetation on the side that doesn't get as much direct sunlight. Alright, how climates affect living organisms. This is a very, very, very broad idea, right? Organisms adapt to their climate. That's how we survive. So polar bears have thick fur and it's white so they can hide. Because they live in snow, that's cold. Pretty straightforward. Cactuses have shallow roots so they can soak up as much water when it falls for water storage. There should be camels. Have water storage system, and they have eyelashes that are very, very unique so that they can keep the sand out of their eyes. Deciduous trees lose their leaves. The types of crops we grow are good for us, but they wouldn't be able to grow in other places. The types of buildings we put up. I believe somebody asked the other day, why do people in, say, New Orleans or those areas in the south put their buildings on stilts? It's so that they don't flood. We don't need to do that because we don't have to really worry about flooding too much. Alright, and that will do it for the first lesson of notes.